Let me kick off a tweet as usual, and then we can get this thing started. I've been looking at TrueType font stuff because I just felt like I wanted to add hinting to STP TTF, and I needed to learn how everything worked roughly to get that process started. So I pulled up the TTF documentation over here from that's hosted on Apple at least. I assume that this is it's been pretty informative. And then as if Gartner has just pointed me to Sean Barrett's little paper here on TrueType, so I'm going to take a look at that and see if it's got anything. It looks like it might have information that I have to like cross-reference with this to make sure that I'm looking at the same types, or maybe the new type I have to know about, or what's going on there. Okay, so let's take a look at this Sean Barrett paper real quick and see what's going on in here. So previous versions of SB TrueType to 1.06 used a simple extension of the traditional scanline filling algorithm to compute horizontally anti-alias scan lines combined with vertical oversampling. Not sure what this last part means. But we'll just press ahead. The SB TrueType 1.06 algorithm, a reinvention of an algorithm generally credited to Lebart, computes the exact area of the concave polygon clipped to each pixel within floating point precision. By computing the signed area, let me get rid of the distraction, the signed area of trapezoids extending rightwards from each edge. So what this means here is trapezoids extending rightwards from each edge. It sounds to me like what it's talking about is if you look at an edge, you can sort of, if you imagine you have a square grid there, and finding the area of that trapezoid that comes out to the right front, when you look at the square and you take what's left there, you can sort of make a trapezoid and figure out the area of that. Although it's not always a trapezoid, is it? Sometimes have 5 sides. I'm not sure exactly what that means. But it's talking about some sort of algorithm for finding how much of a pixel you cover, I think. The assigned area as the coverage of the pixel. So that's like figuring out how much to fade a pixel, basically. This provides more accuracy than sampling, although it is incorrect when shapes overlap, as it measures the area of the shapes within the pixel, not the fraction of the pixel that the shapes obscure. Measures the area of the shapes within the pixel, not the fraction of the pixel that the shapes obscure. So it means if two shapes overlap, okay, so when two overlapping shapes happen, it counts the overlap area twice, is the problem there. Alright, let's see. To determine if a point is within a concave with holes polygon, we classify each polygon edge with a direction. Yes, that was something I learned in the TTF thing. So they tend to wind in a certain direction, and everything on the right-hand side of the line gets darkened, and everything on the left-hand side is not. So, like, if this were the outline of your glyph, like if these were the two contours that were used, you can see that this winds in a different direction than this. And that tells you that the bubble in here will not actually, like, when you fill it in, this should not be filled, this should not be filled, and this should be filled, because it's always the spot on the right-hand side of the line. if you're walking along the direction that the line is defined in. You can see the arrows here pointing, so if you're walking along this line, the right-hand side is this part here, right? And if you're walking along this line, the right-hand side is this part and not this part. So that's how you can tell what's dark and what's not, from what I understand. So everything I explain is stuff that I'm learning right now, so I'm kind of explaining it to learn it, and you're kind of not learning from me, but following along in my learning process to see if I can see how much I can figure out, is really what we're going to do here. So anyway, array from the point to infinity and count the edges it crosses. So we classify each edge with a direction, right? We cast array from the point to infinity and count the edges it crosses using a signed number for each edge. +1 in one direction, -1 in the other. So we cross this line and it probably goes up 1, cross that line and it goes down 1. If the final sum is non-zero, then the point is inside the polygon. The class algorithm for filling such a polygon simply computes the same calculation incrementally. So basically the idea is you can take any point and determine whether it's in a polygon by just casting a line out from the polygon in some direction, figuring out when you cross other lines, and then if you cross, like if I cross one thing, I was inside the polygon, whereas if I go through here, and that means I go like up 1, and then I come through out here and I go down 1, that means the point was outside the line, which is cool. And like if you happen to be like right here, you'd go down 1 to -1, 0, when you went back up 1, and then down 1 to -1 again, meaning you were inside. That's a pretty cool system. But anyways, for any scan line, the green lines above, we can start at a -infinity and scan along the line, counting crossings. Whenever the crossing count goes from 0 to non-zero, we begin to fill the region whenever it goes from... Yeah, so that's if you render by going just left to right across a line. Always end up 0 if it started at 0. There are various things one must be careful about. Example, if a vertex falls exactly on a scan line, we must be careful how we count those edges as crossing that scan line. Okay, that makes sense. So if I draw the scan line that like goes through this point here, you don't want to count that as 2 edges. And like if you look at this vertex, you might say that that counts as going in and out of one, but if you only count one of those or something, you'd get off. So if your line goes through a vertex, you'll have an issue. Purposely drifting. Today I'm learning about how the TTF files work, which involves rasterizing polygons, yes, but also just even more complex than that. It can be a quadratic sort of, I forget what you call them, the Bezier curves kind of thing, right? If I can find the example I was looking at earlier today, this isn't, yeah, like lines like this. This isn't really the part I was looking at when I first started. Introduction, no. Yeah, I don't want to look at that. Introduction. Yeah, this part. Not this part, no. So after introduction, data types, overview of true type, special tables, the font, right? Why am I having trouble finding this now? Digitizing letter form. So this first part that I read, you know, you've got things where you've got points on the curve and points off the curve, etc. And mostly what I'm doing here is I just want to get a basic understanding of how it works, because I'm thinking about trying to add hinting to the STB so that 4Coder will have hinted fonts. And I want to kind of know what I'm looking at before I get in there and mess around. So I'm just giving myself a quick sort of crash course on how everything works in a TTF file, and how things work in a font renderer, and then I'm also going to look at the TTF. I've got right here the TTF file spec, and I'm just going to see what I can find out about how I got to do hinting, right, to an already otherwise complete font renderer. Anyways, I was reading this little article from Sean Barrett, seeing if there's anything in here that suggested, and it's certainly got some interesting information. Gather all of the, and this is talking about how to look at it as a scan line algorithm where you scan from left to right and then you'd have filled regions and unfilled regions. Gather all of the directed edges into an array of edges. Sort them by their topmost vertex. Move a line down the polygon, a scan line at a time. And for each scan line, add to the active edge, makes sense, any edges which have an uppermost vertex before this scan line, and store their x-intersection with this scan line. Remove from the active edge list any edge whose lowermost vertex is above this scan line. Sort the active edge list by their x-intersection, as it doesn't change much from scan line to scan line. Iterate the active edge list from left to right. Sindev, I can't pronounce your name. Sindevolo, Dev, I love pie, Sindelove pie, something like this. I love pie is definitely in there, but I'm not sure. But what I'm working on now is I'm just trying to learn about font rendering so that I can add hinting to something. It definitely all runs through the GPU, but that's not really relevant to adding something that just extracts the hinting information and does the adjustments that needs to be done, if I understand correctly. In my head, hinting isn't too hard, but I just need to know the details before I jump in. And the reason I don't just use libfreetype, a lot of people want to know why I don't want to use libfreetype, and that's because that's a big thing to link to. And so I'm not like doing like if I can continue to ship the program without linking to the libfreetype, I would like that, because linking will complicate a lot of stuff. Like, I like having the code just be a small thing that is all code that doesn't link to outside stuff. Plus, the STB library needs hinting, and if I can help to improve the STB library, that would be awesome. And that's also a factor. Alright. That makes sense. So anyway, for anti-aliasing, we want to know approximately how much of each pixel is covered by the polygon. For efficient implementation, we treat the pixel as a little square and literally just measure the coverage of that square. This is equivalent to using a box filter, which, while not necessarily ideal, is a reasonable trade-off of performance for quality. Okay. That's algorithm somewhere, or if I reinvented it myself, but it is a pretty straightforward extension. In the above algorithm, we treat scan lines as infinitely thin 1D lines. Then we only sample the crossing count at, say, pixel centers, despite the fact that we have more information about the horizontal axis. Right, so he's showing pixel centers here and figuring out when crosses happen relative to those. Again, the main reason I don't want to use FreeType the FreeType library is because it complicates things if I have to link to an external thing. Right now, I'm able to not link to anybody in the main application code, and it's possible that I wouldn't need to link to anything anyways. Like, I could find a way to put libfreetype in there and not link to it from the main part of the application code. I just want to avoid that if I have to. Plus, it's a big piece of code compared to STB TTF. So if STB TTF had hinting, like that's the only thing it's got to have, I wouldn't need to switch. So alright, I'm reading this down, which I wasn't meaning to do. We've divided the lower scan line into multiple pixels. You can see the pixels where each blue tick mark represents the boundary between pixels. Okay, those aren't centers, those are boundaries. We can easily measure how much of the scan line segment between two pixels is inside the polygon by coloring the parts of the line that are inside a different color. Right, makes sense. So you're saying, like, look at this pixel, how much of it is covered? And the answer is, well, how many times does it change in there? And it's like, oh, it changes here, so from there to there's how much is covered, and there's no more changes, so the rest is uncovered. Or this one, how much is covered is the amount from there to there. And that's actually not too hard to imagine computing. Pixel number 1 is about 25% pink. Pixel 3 is about 80% pink. And pixel number 4 is 100% pink. Thus, we can determine that the one-dimensional anti-aliasing coverage of each of those pixels are 25%, 80%, and 100%. Right, okay. So that's kind of what I was imagining. Alright, so here's a new algorithm. I imagine this new algorithm I developed for STB TrueType 1.06 has already been published. Okay, so this is about STB TrueType 1.06, not a file format. So I think the file format doesn't actually change, but I'm going to read this because it's about how STB TrueType works, and that's what I'm going to be messing with anyway. Alright, so the core idea behind this algorithm using signed areas came from Maxim Sheminarev's anti-grain geometry source code. My coworker Fabian Giesen investigated that code to learn how the anti-alias rasterizer worked and came back with an incomplete understanding of the details but a suspicion of that core idea. He shared the core idea with me and I reworked a brand new algorithm from first principles based on it. Okay. Found other write-ups of this algorithm here and here. However, I think this article is still generally clearer and more thorough, and some of the ideas are handled slightly differently. Alright, sounds good, so we'll keep reading this one. Signed area. A classic algorithm for measuring the area of a concave polygon is to complete the signed area of a number of triangles, one per edge, and sum them. So for each edge there's a triangle, he says. I'll have to confess I don't totally know what I'm looking at with these triangles over here. Compute the signed area of a number of triangles, one per edge, and then sum them. Okay. It requires computing a cross product per edge. Now I'm guessing one thing that looks like it's happening is all of them have a similar point right here. So it's like, if I take a point there, then it's like subtracting this area, adding this area, adding this area, adding this area, subtracting this area, and adding that area. It kind of looks like it would work, right? Because anything, like, you'd have to do a little bit of geometry to prove it, but it looks like anything that gets subtracted is also something that got added somewhere else. And the only trick is to figure out whether to add or subtract a triangle. And I think these red ones are saying subtract these ones. Alright. Perhaps less frequently used, but based on the same principle, one can measure the area as the sum of the signed area of a number of right trapezoids. Okay, this one makes sense to me too, which is you take the area here, like from a baseline, and you take each of these edges and you just measure down. So like here's a positive section, here's a positive section, and here's a positive section, and then there are several negative sections, and you subtract the negative sections, you add the positive sections, and that gives you an area. That's a really interesting system. I like it. It's particularly easy to compute, and these fit very well into the scanline framework. Yep, true, okay. Conceptually, the new anti-aliasing algorithm computes the area of the entire polygon clipped to each pixel and uses that as the coverage for the pixel. Okay. Very little clipping is actually involved, and in practice most of the algorithm is nearly identical with the active edge list logic from the previous algorithm. Gather all of the directed edges into an array of edges, sort them by their topmost vertex, move a line down the polygon, a scan line at a time, where a scan line is now 1 pixel tall rather than infinitely thin, and for each scan line, add to the active edge list any edges which have an uppermost vertex within this scan line, and store their x intersection with this scan line. Because the edge list has been stored by topmost y, edges from the edge list are always added in order. Add to the active edge list any edge which has an uppermost vertex within this scan line. Okay, so you're looking at a scan line which has a certain amount of width. Anyone within that section, you say, if you have your uppermost vertex in this section, add it to the active edges. Right? Remove something if its end has, like, if we've gotten to a point where the end is above this point, we're going to remove it from this active edge list. Compute the signed area, pixel coverage of the scan line. So you look at each pixel, signed area, pixel coverage of the scan line, right? So you're looking at how much of it is covered, advanced every active edge to the next scan line, or next x intersection. Nice. That's really cool. Because they're straight lines. For now, anyway, these are straight lines. I'm not sure that that actually makes any sense because you've got curves in there. But for polygons, it works. We want to use signed trapezoid areas to compute the pixel areas. The illustration above showed trapezoids filled the bottom edge, but we'll use trapezoids filled horizontally to the right edge of the bitmap. In other words, we want to compute something like the following, where pixel represent from edge of the area. I see. So this is not positive and negative anymore. Now it's this edge is contributing this much, and then it's contributing blah, 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 blah. Okay. It says right there, not the sign of the area, which is what it was above. Okay, here each edge contributes a right. Let's see. Process E edges. This is going to talk about optimizing that algorithm, which I'm not too concerned about. Alright, so now the one thing to think about that he's saying here is, up here, this is must be an edge that moves this direction, right? This edge moves from here to here, that edge moves from here to here, because as we've said, it's the right-hand side of an edge that's darkened, and the left-hand side is not colored. And if you have an edge, you have to worry about whether or not it's positive or negative, because an edge that goes from here up, then that would be positive, but if it starts here and goes down, that's negative, because this area here wouldn't be colored, it would be empty. So that is a negative area then. You just compute the same thing and you make it negative, I'm guessing. Which is the opposite of case 2. Northwest to southeast slopes. We can write case 2 strictly in terms of edge that slope northeast to southwest, regardless of direction. To handle edges that slope northwest to southeast, we simply flip these edges vertically, not swapping the endpoints, but actually flipping the y-coordinates and negating the slopes. And then use case 2. So he's saying basically okay, that's just a detail about how he's getting the signs right for all that stuff. Okay, this code here is in STB true type. If x top is greater than x bottom, y0 equals y bottom minus y0 minus y top, y1 equals y bottom minus y1 minus y top. Okay, so it's not just flipping, it's not assigning, it's not swapping the y's, it's actually got some, it's within the pixel range, turning it upside down. Okay. Let's see. Compute intersection with y-axis at x1 plus 1, y crossing equals x1 plus 1 minus. Right, this is what I was saying earlier, so overlapping polygons have an issue. Alright, so that's an interesting article. Not, I mean, it'll be useful when I start looking through the code. Let me catch you up on what I was reading over here in the, actually, let me pop that open and save it. Okay. What I was reading over here is about, you know, they have off-point curves. It described as your curves a little bit, showed how you can make glyphs with one or more contours. Like this one has 3 contours. With these points, some of them being off the curve. And then down here it's talking about what to do when you have 2 contours overlapping and how they don't, like, they just, it's sort of an or. If this is showing the center of pixels, not doing any anti-aliasing, but it's saying like if the center of the pixel is inside any one of the contours, like the contour 1 or contour 2 or blah 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 blah, then the pixel is colored. That was some stuff I didn't really care about. Right here it's talking about defining the points of the glyph, because it's all done in fixed point, so the grid is specified to have a certain amount of resolution, right? There's a certain resolution of grid that you stick the points onto when you're saving it or something like that. If I understand correctly, it's like this is, it depends this is like advice to people making fonts. Which one you pick gives you more resolution on the points of the grid. This is talking about alignment issues. So some of this is advice on how to format your font, like if you're making a font. But then if we go to, let's go back one. the reference manual, the font engine, things start getting more interesting. So I was looking here, and it's talking about here just how the basic font engine works. So right here is where I kind of left off, and we'll keep looking at this. 1 minute. Okay, I've got a little bit more time. Less than I thought, but we can keep going for now. Alright, yes, a TrueType font serves a master outline when an application requests a particular glyph at a specific size for a specific device. The font engine will create the necessary bitmap. Now this is where I'm wondering what it's talking about, because this might not be about the file format as much. Maybe it'd be better to switch to the file format at this point, because I've learned a lot from what the things I've read already. I might be able to decipher what the file format itself is at this point. Because this is talking about like getting into their font engine, and that might not actually be about the files as much. Like that's an interesting picture there. 2 lines or curves that join together immediately after. And of course anti-aliasing and hinting are both things that solve that. Alright. Yeah, and there's also this whole thing with interpreter and instructions. Interpreter. I'm going to go ahead and say that that's about as far as I want to go on this right now, because I'm not sure how much that is relevant. So I'm going to switch to this. Alright, this is the actual documentation for how the file format looks. So they've got some definitions here. This is particularly interesting. The fixed point format consists of a signed 2's complement mantissa and an unsigned fraction. So that's not really fixed point then, is it? I mean, fixed point doesn't have a mantissa, does it? No, wait, oh, okay. That's not, mantissa is not the exponential part, right? So this is fixed point. 2's complement mantissa and okay, so it's 16 bits, and the first, basically, it's 16 bits, and if I do the math out, it looks like one of those bits is being used for a sign. One of those bits is available for, like this right here is a 2-bit integer, signed integer basically, right? So you've got 0, 0 goes to 0, and 0, 1 goes to 1, and then 1, 0 goes to -2, and 1, 1 goes to -1, right? So that's a 2's complement 2-bit integer right there. And then the other 14 bits are an unsigned fractional part, and whatever number you store in that 14 bits is being divided by 16,384, right? So really what you have is you've taken your 16-bit number and you've said that there's a decimal point after this point, right? So it's just 16-bit numbers divided by that number, right? It's whatever the actual value of one of these things. This is the way I always think about fixed point numbers, is just know what are you divided by at all times, because that tells you what you have to do when you multiply. So 16,384, right? You take if you look at your 16-bit signed integer and you interpret it as a normal integer and then divide by that number, 16,384, you'll get what it is, what that fixed point represents. And so like if you do multiplications, you just have to make sure to multiply by this number here afterwards and stuff like that. And that should be 2 to the 14. if I've understood everything correctly, or it might be 13. I'm not, you know, there's always like that off by one possibility in these kinds of scenarios. Is there really no power button in programmer mode? 2 to the power of 14. Yeah, okay. So that's nice to know. Alright. Yeah, bit shift. If you take a 1 and you bit shift it 14 times, that's the easiest way to compute this number. Correct. So anyways, that makes sense. The table directory begins at byte 0 with the offset table. Begins at byte 0 with the Alright, so this is talking about the first byte of the table. It might be useful for me to like write code about this. Whenever I'm trying to understand a file format, the easiest way for me to like keep track of what I've learned is to make sure I'm writing the code that describes it. So that it's kind of like notes. So I'm going to just open up an Emacs thing real quick and go, this isn't going to be real code, I don't think. It's just going to help me to keep notes on how this actually lays out. And I like to take notes in C rather than in English, because it makes more sense. Okay. Fixed. What does that mean? Wait, that's a byte. This is 32 bytes. Right? Oh, okay, well everything was right as long as, no. Signed integer, fixed up here says 32-bit signed fixed point number, which is being divided by 65336, or whatever that number is. Yeah, 65536, so that's fixed. And what's this? The fixed point format consists of a signed 2's complement mantissa. I don't know. Okay, so I don't think this is the actual format in the thing. This is like they used a smaller example, like for 214, but their actual fixed numbers are 1616. Is what it looks like. Right. So if their actual fixed numbers are not actually shifted by this much, that was an example, and this is all a lie. But all I really need to know is that it's x divided by 65536, and that we're doing a shift by 16 to get the integer version of the fixed point numbers. Okay. And so that's how you encode a 1 in their system. Makes sense. Alright, so that's the first thing. Let me plop that down right here. That's like, come on. Version. Whoops. Version. Okay. And then I'm guessing U short is 2 bytes. Yep, 16 bits. Okay, so 4 U shorts. Let me put this over here. Let me set this up to be right here. Side by side, even better. We can delete this one. Whoops. Yeah, okay. So that's like unsigned shorts, number of tables. We're going to have 4 of these. Search range, entry selector, and range shift. Whoops. Okay. So that's the first, that's the offset table they call it, I guess. So that's a number of tables, search range, maximum power of 2 less than or equal to number of tables times 16. I'm not sure what that means. Entry selector, log base 2, maximum power of 2 less than or equal to number of tables. So that's, okay, the largest power of 2, so they mean the like maximum power of 2 that's larger, less than or equal to the number of tables. So if I have 20 tables, the largest power of 2 that's less than or equal to that is 16, and then that's times 16, and this one is log 2 of it. Alright. So those are just like pre-computed values that you could kind of get for yourself if you wanted, but why should you have to do the work if they're going to just put it in there for you? Number of tables times 16 minus search range. Interesting. I mean, it makes some sense. Just don't know what they're going for yet, but okay. It's byte 12. So the 12 bytes, they say that's 32. Wait, no, not 32. That's 32 bits. So that's 4, 8, 10, 12, right? That's 12 bytes. By 12 by the table directory. So this right here is not called header. It's called offset table. Underneath that we have table directory. And in here we have unsigned longs. How long is an unsigned long? Is that 32 bits? Okay. Tag. Checksum. Okay, can I just say something real quick? I know I didn't complain about this at the right time, but it's just now starting to bug me that they did that. This doesn't make any sense. Why would you give an example of a 16-bit fixed point number in this format when that's not actually part of your, like, you're not actually defining anything that way? Why would that be there? It just wasted a lot of my time. Okay, back to this. Okay, offset from the beginning of a true type font file. Offset from the beginning of true type font file. Alright, this is an entry table directory entry, right? Because there's more than one of these. We have a tag, a checksum for the table, the offset where the table starts, presumably, and the length of the table. Okay. And this right here tells you how many of those there are. Okay. Now, what I like to do at this point is to do a sanity check by saying, let's take a look at a TTF file and see if everything lines up the way it's supposed to so far. Before I go too deep into this, I want to make sure I'm actually going to find what I'm looking for. Alright. Grid fitting and scan conversion. Alright, this table contains information which describes the preferred rasterization techniques for the typeface when it is rendered on a grayscale capable devices. This table also has some use For monochrome devices which may use the table to turn off hinting at very large or small sizes. Grid fitting that sounds like hinting at very small sizes, the best appearance on grayscale devices can usually be achieved by rendering the pixels in grayscale without using hints. At intermediate sizes, hinting and monochrome rendering will usually produce the best appearance. At large sizes, the combination of hinting and grayscale rendering typically produce. Okay. So yeah, it looks like there's hinting in here. If the gas table is not present in a typeface, TrueType will apply default rules to decide how to render the glyphs on grayscale devices. Consists of a header. Alright, let's see if there's any more mentions of the word hint. How far down did we just jump to find that one? Grid fit is so close to what I care about. 2 flags for the range gas behavior flags. Use grid fitting, use grayscale rendering. Okay. Number of records to follow. Each gas parent looks... Okay, anyway, I want to see if I open up a TTF file, if I get roughly the thing I'm looking for so far. Connor Rent asks, what's the document? I'm looking at the TTF spec. If you'd like to know where I got it, I forget. But I could help you by giving it to you at some point. Not right now, because I'm a little pressed for time, and I want to get at least on the screen making sure that I'm understanding these headers correctly. Okay. Alright, so fseek file 0 seek end seek set result size equals ftell the file. If result size is greater than 0, then result data equals malloc all of that. Result size. And to explain what I'm doing, Connor, I'm considering this my practice first of all today, but I just been kind of curious to see if I could add hinting to STB TTF, because if I can add hinting and it works well, then that's it. Like, that's all I need my fonts to ever do. So I wouldn't have to switch to lib free type, and STB is so much smaller and easier to use that I'd really prefer to do that. So if and it would be nice to be able to contribute, like if I can make a good enough implementation of hinting, maybe I can contribute that back to the STB libraries altogether, which would be really kind of fun. So I'm seeing if I can get a handle on the hinting stuff, but to do that I need to be able to parse the file format. So that's the first thing I'm doing, is just sort of getting my head around the file format, figuring out where the hinting is, and then when I get into the STB code, hopefully I can figure out how to get hinting information out of the STB stuff. And yet, Magpie has found the document that I have. Alright, so that gets me that. And I need to fread into the data all of the bytes from that file. Okay. Okay, so that gets me a file, and then from then on, what I want to do is first I need to look at the offset table. Right? Yep. And what I normally do for reading a file is I have like a cursor pointer, actually, that I can advance around as needed. So it'll go like cursor equals file data, offset equals offset table cursor, cursor equals, and then the annoying thing is simply that there's no type. I wish there was a type that, I wish void you could byte arithmetic with it, but you can't. So let's see, take that, and I want to do offset plus 1, because that advances 1 past that, and that should be 12 bytes exactly, and it says that the 12 bytes there, so that should be exactly 12 bytes ahead, and that gets me to one of these from up here. And I'm convinced there's hinting information in the file, so that's good. I'll at least be able to extract hinting information, I believe. And then I just have to do the work to learn how you apply it before you do the rasterization. I don't see how this can be too bad. I mean, all of the hard work has been done by Sean. I just have to shift some pixels around by a small amount, and my job is done. Yes, this right here. So I want to see if we can get these table directory entries, right? So for that to happen, what I would have is like table number. Well, that'll be just in the offset. Well, I'll throw in a holder for it. Equals offset table number, and then I'll do something like table directory entries equals table directory entry the cursor, and then while I is less than the table number plus I should be able to look at each of these. So then what I just want to do is have like print functions for all of this stuff. So here's the offset table, print that, and then here's each of my table and directory entries plus I. Just got to write these print functions real quick, and we'll be able to call it a day of stream anyway. I'll have more of this to do. I just can't do it on stream until I get some stuff moved around, taken care of. Okay. So here's the version number, and that is offset version, I believe. Yes, but I have to bit shift it by 16. Here's the number of tables. Offset num tables. Alright, just a few of these. And that shouldn't actually be a D, but if I do that, it'll work. of tables, search range, entry selector, range shift, entry selector, range shift. Alright, there's for the offset, and then I want one for the table directory entry, which is like this. What do we have in here? Here's a tag. Actually want that in hexadecimal. How do you... I can't remember... printf hex integer. That was extraordinarily unhelpful, actually. Okay, now I think I get it. I'll do it like that. Right, how many, if you have 4 bytes, 1 byte is 2, 4 bytes is 8. Yep, okay. So here's a tag. Let me pop open the docs real quick. Here's a checksum. I think I'll do that in hex as well. Okay, offset we can do back in normal land. These should all be unsigned, and I'm not marking them as unsigned, but I think that's just like UD, if I remember correctly. Yeah. Offset and length. Okay. Now I don't have a batch file for this one, so I can't just build from Emacs, but it's not going to be too bad. It's going to actually be annoying now that I think about it, so let me do it the proper way. misc build yeah, just give me an example to follow. Build ttf.bat. Alright, so this bat needs to echo off, push D into the build directory, and then pop D, and it needs to see, let's see, I want the same that I always use for those. Warning, autocomplete doesn't work in this mode. Go to the code, get fored ttf.h, I believe is what I called it. Yep. And build that. Spit out a fored TTF file. Make debug symbols. Okay, and while I'm messing with my build, might as well direct this at this one, build TTF. Cannot read at OK. That's weird. I don't know what that means. Yeah, I really didn't know what that's talking about. Build TTF. Now that should work. Well, I'm pretty sure that it doesn't matter. But there it is. That also doesn't seem like it should matter. Forward ttf.h, control x delete forward ttf.cdp, code, delete forward ttf.h. There we go. Num tables. There we go. Alright, now what I want is, ooh, I need another bat. I always have to add, I should automate the process of adding new bats, actually. But here's my run. Now let's do run TTF. Actually, that's not helpful at all. Show me this one. For a TTF. Perfect. And now I want to set this to run TTF bat for now. Now I should be able to run it. Could not open test TTF. That's true. What do we have here? We have some TTF, so let's copy liberation mono.ttf into test.ttf. Now let's run it. That's not really what I wanted to see. Alright, so I forgot some new lines here and there. And I'd kind of like to debug this. So there we go. Alright, so, step into here. Hey, Petey Daddy, I see you in the, chat window, and I just want to take a quick moment to say hi, because I know last time you were here we, discussed a Mac port, and I'm just curious if, you got a message. I tried to get in touch with you, so that I could stay in touch, because I wasn't sure how else I would find you, but now you're back, so I can call you out on stream. But yeah, I'm working on improving STB TTF because that's literally the only external code I have, and it's so small that I can link it into the program easily. So cool. So yeah, I just wanted to see if I could add hinting, because if it had hinting, I would never need to switch, and that would be great. And also, it'd be nice to be able to contribute to something like the STB, because it's a great library. So let's see. Alright, so we should be able to get our info. What does that say? Offset. That doesn't seem great, does it? Let me look at offset as if it were 12 bytes. Okay, so that makes sense, right? It says 256 because you've got a 1 there, and those are low order bits. What? If that's version 1, the low order bits contain the high order information? Really? Well, that's not fabulous. Is this like in little endian or something crazy? What's going on here? So after the first 4 bytes, the next 2 should be the number of tables. So there's 4 bytes, and here's 4 or 5. 16 tables or 40, 96 tables. Probably 16 tables, right? And what's the next number? Checksum for this. No. Search range, which is the largest power of 2 less than or equal to the number of tables times 16. Okay. Well, if we assume that this number is supposed to be 16, then this number here if you did 16 times 16 would be 250. Yeah, this is like in little endian or something, right? Am I crazy? Because this right here... No. What is it doing? I mean, I get these confused a lot, but why would it do that? Right, if this 1, 0 comes out as a 1, is it like interpreting these as little endian? Like, why would my system... That doesn't make sense. Alright, tell me if I'm crazy, right? Big endian means lower address is higher value byte, right? In a 2-byte integer, the lower value byte has the higher weight if it's big endian, right? Okay, so the big end of the word comes first. So what's going on here? Because if you look at this is 4 bytes, right? For this. This is 2 bytes right here and here. So 6 and 7 are that 1. That means it's interpreting the 1 as coming like that should be the big one. Why is it interpreting it small endian? What's going on there? Am I crazy? I'm totally lost right now. That should be 256, right? 6 and 7 should render as 256 here. That right there should be 65536. Well, don't worry about what the file is supposed to be. I mean, I think that the file says it's supposed to be big endian. The doc says it's big endian. But let's ignore that for a minute. And let's talk about why is the debugger saying, why is my code interpreting this as a 1 when clearly that's 256, right? This number here is a 4-byte number, and that is being interpreted as 256, as if the first thing is the lowest order and the second thing is the next one up, and then the third thing would be 65536. But that's backwards from what that actually is, right? That should be 65536 on the version. So what's happening? What am I missing? What am I missing? Because, yeah, it thinks the version is 256. The confusing thing here to me is that it looks like Miblo, the version doesn't start at offset 1. What happens is this is a fixed point floating number, so it's actually, the number is 65536 and it gets bit shifted 16 bits. So let me show you where it says that. Version 1 should contain a 0 and then a 1 and then 2 zeros, because it's a fixed floating point. It's a fixed point fractional. So the lower 2 bits are actually fractional, and these 2 bits here are above 1, right? But that means this, if you see this, that should be 65536. But it's looking at that and seeing 256 instead. I feel like I've lost my mind somehow. Cursor. Why? Any tips, people? If not, I'm gonna have to call it off because I've not got time to deal with this. But why would on earth I be seeing this? This doesn't make sense to me right now, and I'm missing something. So if I take a look at just this, these first 2 bytes here are being interpreted as 256. That's little endian, right? insofar as maybe you can help. Look at the output from my debugger right now. I have cursor here and cursor here. Cursor is looking at this one right here is looking at each byte individually, and you can see it's a 0 and then a 1. If I cast it to a short pointer, it thinks it's a 256. Shouldn't this be 1, 0 if that's a 256? Isn't this representing little endian? Like, doesn't this seem to say that my computer is behaving like it's a little endian right now? Like, why would that be? What am I missing that is making that not true? Right? How have I confused myself here? Because it looks like my computer's interpreting this as little endian for some reason right now. It's never been little endian before. Like, this is completely absurd. I've never once looked at output from my computer and seen little endian. Well, apparently my computer is a little endian computer right now, so there have been computers. Because this one just became little endian or something. I'm totally, like, I have no idea what this is. I have to get going, but I need to, like, this is incredible, so I'm going to do one other thing real quick. Since when are x86 and x86-64 little endian, really? I thought everything was big endian these days. Like, I didn't think you could even... And I'm pretty sure that everything else I've ever debugged was big endian on here. Here's a similar project that works. This was working recently, and I'm pretty sure... Everything's little endian? Oh, I got it backwards. Right, little endian is the norm. Oh, gotcha. Well, yeah, I just flipped them in my head because I was assuming that this file did the normal thing. But what I have to actually do is say that I need to flip this because this is encoded big endian, and big endian's the weird one. Okay. For some reason I was thinking big endian was the normal one. Right, okay. Alright, so that's how I confused myself. Mystery solved. I'm just really dumb. Everything is little endian these days, not big endian. Okay. In that case, the issue to deal with first is byte reversing everything, right? So, that'll be kind of fun. This is kind of fun because I've never in my life had to actually fix this. Like, even though I used to think about it once in a while, like played with it, I never actually had a real world thing where I had to byte reverse something. So this turned out to be a fantastic practice. So everything gets byte fixed. Okay, it's still craziness. So I'm going to stop it, and we're going to look at it real quick through the debugger. One time through. Alright. So now the offset should make some sense. Hopefully. So that's a 1. 16 tables. 16 times 16 in the range. Leftover is 0. Entry selector 4, because that's 16 modulo, or log base 2. Alright, so what did we just get now? Version 1, number of tables 16. Yep, awesome. Table number. I stored table number too soon. That's not good. Gotta byte fix it before you read anything out of it, or you're gonna lose. Think we've got success now. Alright, it's kind of, I want to make that easier to read, so alright, there we go. So we have, let's do one actually like this. Okay, so we have all that, and then we have these things here, which are yeah, those are hexadecimal numbers. There and there. Those two aren't, but they still have a D incorrectly. Let's just say, interpret that as signed and hope that it's okay. So, 16 tables. Each one's got a sort of an offset and a length. These look like pretty reasonable numbers, so I would say we're interpreting the front of the file correctly. And that's all I've got time for today. Thank you very much for joining me for